Have you ever imagined what it would feel like to drift endlessly through the vastness of space, surrounded by nothing but darkness? No sun to warm you, no nearby stars to guide you, only an eternal ocean of emptiness. Now picture a massive planet slowly appearing in that void, a world without a home, without a star to orbit, a lonely wanderer drifting aimlessly through the cosmos. It sounds like the opening scene of a science fiction movie, doesn't it? But here's the surprising truth. These worlds are not just science fiction. Astronomers believe that out there, hidden in the darkness between the stars, there may be billions of such planets. They're known as rogue planets, worlds cast adrift, exiled from their solar systems, doomed to roam the galaxy in complete solitude. But where do these mysterious planets come from? Why were they expelled from the safety of their stars? And here's the bigger question. Could there be a hidden world, a mysterious Planet 9, quietly lurking at the edge of our own solar system? In today's video, we'll explore the strange and haunting reality of rogue planets, how they form, and why they are thrown into the darkness. The difference between true rogue planets and failed stars, called brown dwarfs, and the latest evidence that suggests there could be another giant planet hiding far beyond Neptune. And finally, we'll step back and ask a profound question. Among the countless lost worlds scattered across the galaxy, is Earth just another lucky survivor that hasn't yet been cast adrift? This is the story of the lost worlds of the universe. Let's begin. Welcome to Astronomical Library. When we think of planets, we usually picture them orbiting a star. Earth orbits the Sun, Jupiter does the same, and in distant systems, countless exoplanets circle around their own suns. A planet without a star almost feels unnatural. And yet, rogue planets may actually outnumber the stars themselves. So where do they come from? Astronomers propose two main origins. The first possibility is that rogue planets are simply planets like Earth or Jupiter, born inside a young solar system but later kicked out. In the early days of a solar system, gravity is chaotic and violent. Imagine dozens of newborn planets and giant chunks of rock all pulling on each other, like a cosmic dance gone wrong. Sometimes, these gravitational battles end with a planet being thrown away, ejected at tremendous speed, strong enough to escape its star forever. Once that happens, the planet is on its own, cast into the black sea of space. The second possibility is even stranger. Some rogue planets might not have formed around stars at all. Instead, they may have formed directly from collapsing clouds of gas and dust, just like stars do. The difference is size. If the collapsing mass is too small to ignite nuclear fusion, it never becomes a star. Instead, it becomes a planet-like object, drifting freely from the very beginning. This leads to a fascinating puzzle. How do we tell the difference between a true rogue planet and a failed star? Here's where we meet the so-called brown dwarfs. Objects too massive to be called planets, but not massive enough to shine as stars. They exist in a twilight zone between definitions, glowing faintly with leftover heat, but never igniting like real stars. A rogue planet might be smaller, colder, and darker, while a brown dwarf is heavier and slightly brighter. But in the lonely darkness of interstellar space, the line between them can be blurry. Now, you might wonder, how many of these lost worlds are really out there? A survey in 2021, using a powerful technique called gravitational microlensing, gave us a shocking estimate. This method relies on gravity itself. When a planet passes in front of a distant star, its gravity bends the starlight just enough for us to notice. By watching these cosmic lensing events, astronomers can detect objects that would otherwise be invisible. And the result, the data suggests there could be at least one rogue planet for every star in the Milky Way galaxy. Some studies even hint at higher numbers, meaning there could be hundreds of billions of lonely planets, drifting silently in the dark, more common than stars themselves. Think about that for a moment. When we look up at the night sky, we see billions of shining stars. But hidden in the darkness between those stars could be even more planets, invisible to our eyes, each one carrying its own unique story of creation and exile. Some may be small, rocky, and barren. Others could be gas giants, like Jupiter, still holding on to faint ghostly heat from their violent birth. And who knows, a few of them might even carry thick atmospheres or underground oceans, making them unlikely but possible candidates for life. Rogue planets remind us that the universe is not always orderly. It is chaotic, unpredictable, and sometimes cruel. Whole worlds can be born, only to be cast away, wandering alone for billions of years. Yet at the same time, these lost worlds make the cosmos richer and stranger than we ever imagined. And this brings us to a haunting question. If rogue planets are so common, could there be one much closer than we think? Maybe even hiding at the edges of our own solar system. When we talk about rogue planets, it's impossible not to mention their mysterious cousins, the so-called failed stars. These are objects that blur the boundary between what we call a star and what we call a planet. Astronomers have given them a haunting name, brown dwarfs. But what exactly are they? To understand this, we need to revisit how stars are born. A star begins life as a massive cloud of gas and dust. Gravity pulls this material inward until the core becomes so hot and dense that nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. This is what makes a star shine for billions of years. But what if the collapsing gas cloud doesn't have enough mass? If it is too small? Less than about 80 times the mass of Jupiter, the core never reaches the critical temperature for sustained hydrogen fusion. Instead, it becomes something in between, not massive enough to shine like a star, but far more massive than any planet, that is, a brown dwarf. At first, a newborn brown dwarf still glows faintly from the leftover heat of formation. But unlike real stars, it quickly cools and fades, becoming almost invisible in ordinary light. This is why astronomers often call them failed stars. They started down the path of becoming stars, but never fully crossed the threshold. So here's the fascinating part. How do we tell the difference between a giant rogue planet and a small brown dwarf? Brown dwarfs are usually heavier, somewhere between 13 and 80 Jupiter masses. At the higher end, they sometimes fuse deuterium, a heavy form of hydrogen, but never enough to sustain long-term fusion like stars. Rogue planets, on the other hand, are lighter, below that 13 Jupiter mass threshold. They may be born in a solar system and kicked out, or formed directly in isolation. But in practice, the line is blurry. Imagine trying to identify a faint, cold object floating alone in the dark, tens or hundreds of light years away. Is it a massive planet? A tiny failed star? Sometimes we simply can't be sure. This twilight zone is what makes brown dwarfs so intriguing. They're not just rare curiosities either. Surveys suggest that our galaxy could contain hundreds of billions of brown dwarfs, lurking invisibly between the stars. In fact, the nearest star system to the Sun, Alpha Centauri, has a hidden neighbor, a pair of brown dwarfs known as the Lumen 16 system, only about 6 light-years away. They're so faint you'd never see them with the naked eye, yet they are among our closest neighbors in space. What's more, some brown dwarfs are known to host weather systems, just like giant planets. Observations with infrared telescopes have revealed clouds of metal and silicate dust, storms larger than Jupiter's Great Red Spot, and even rapid changes in brightness as their atmospheres churn. In many ways, brown dwarfs are like gigantic planets that never found a star to orbit. For astronomers, studying brown dwarfs is more than just curiosity. They act as a bridge between stars and planets, helping us understand how both form and evolve. Are they simply oversized planets? Are they undersized stars? Or are they a unique class of object, deserving their own definition? One thing is certain. They remind us that nature doesn't always fit neatly into the categories we try to impose. The universe loves to exist in shades of gray, or in this case, shades of brown. And just like rogue planets, these failed stars deepen the mystery of our galaxy. Imagine billions of faint, invisible worlds drifting quietly between the stars. How many of them are out there? How many are close by, just beyond the reach of our telescopes? And could one of them even be mistaken for a hidden planet in our own solar system? That question will lead us into the next chapter of our journey. The search for something closer. Something that might still be waiting to be discovered at the frozen edge of our Sun's domain. Until now, we've been talking about rogue planets drifting through the galaxy, far beyond the reach of our Sun. But what if the clues to their existence, or something very much like them, are hidden right here, in our own solar system. To explore this mystery, we need to travel far beyond the familiar planets, past Jupiter, Saturn, Uranus, and Neptune, beyond even Pluto, out into the icy frontier known as the Kuiper Belt, and even farther still, to a strange realm where the sun is no more than a bright star in the sky. In this frozen wilderness lies one of the most mysterious objects ever discovered. Sedna was first spotted in 2003, and from the very beginning, it stood out. While Pluto orbits the sun at distances between 30 and 50 astronomical units, Sedna's orbit takes it out to an astonishing 1,000 astronomical units at its farthest point. That's 1,000 times farther from the sun than the Earth. Even at its closest, Sedna never comes near the main planets. It is an outcast, trapped in a bizarre elongated orbit that doesn't seem to fit with anything we know. Sedna's orbit is so unusual that astronomers started asking, what put it there? Why would a planet-like body follow such a strange path, far beyond the gravitational influence of Neptune? One idea is that something massive, perhaps another planet, hidden in the outer solar system, could have tugged Sedna into this orbit. And Sedna is not alone. Over the years, astronomers have discovered more objects with similar patterns. These are called extreme trans-Neptunian objects, or ETNOs for short. Like Sedna, they have elongated tilted orbits that never come close to the main planets, almost as if they are being shepherded by some invisible hand. Here's where the mystery deepens. Many of these ETNOs appear to cluster together. Their orbits are strangely aligned, as though they are all being pulled in the same direction. Statistically, this is not something that should happen by chance. If they were just random, we'd expect them to be scattered in all directions. But instead, they seem to point somewhere, towards something massive, something unseen. So what could it be? Some scientists suggest that these unusual orbits are evidence for a hidden planet, a world perhaps 5 to 10 times the mass of Earth, lurking far beyond Neptune. This is what has come to be known as Planet 9. But before we get ahead of ourselves, let's pause for a moment. Sedna and the ETNOs are not just numbers on a graph. They are real worlds, frozen time capsules of the early solar system. Their existence tells us that the outer reaches of our cosmic neighborhood are far stranger and more complex than we once thought. Some theories suggest that Sedna itself might have been captured from another star system, billions of years ago, when the sun was still young and surrounded by sibling stars in a stellar nursery. If true, that would make Sedna a kind of adopted child, an interstellar visitor, who found a permanent home at the edge of our solar system. Others argue that Sedna and its cousins might have been shaped by passing stars, or even by the collective gravity of the Milky Way itself. In other words, the edge of the solar system is not just influenced by the sun, but by the entire galaxy. Whatever the explanation, Sedna and the ETNOs are the breadcrumbs leading us toward a larger mystery. Their odd orbits suggest that something massive, and as yet unseen, is waiting out there in the dark. A hidden giant that could rewrite our understanding of the solar system. And that brings us naturally to the next chapter. The hunt for Planet 9. Is it real, or are we chasing shadows in the cold outer night? In January of 2016, two astronomers, Mike Brown and Konstantin Batygin from Caltech, made a bold proposal that shook the world of planetary science. They suggested that all the strange orbits of Sedna and the other extreme trans-Neptunian objects might be explained by the presence of a hidden giant planet, lurking in the far reaches of the solar system. They called it simply Planet 9. So what is Planet 9 supposed to be? According to their calculations, it would be a mini Neptune, a world about 10 times the mass of Earth, orbiting the sun hundreds of times farther away than we do. Imagine a planet so distant that a single year there could last between 10,000 and 20,000 Earth years. It wouldn't shine on its own, and from Earth's perspective, it would be incredibly faint, practically invisible to our current telescopes, unless we know exactly where to look. The idea sounds almost too good to be true, but the math works. The gravitational pull of such a planet could naturally herd the ETNOs into their clustered orbits. It would also explain other puzzles, like why some distant objects are tilted in unusual ways, or why the plane of the solar system itself is slightly off balance. Of course, This leads to the bigger question. Where did such a planet come from? How could a giant world end up so far away, on an orbit so extreme? Scientists have proposed two main possibilities. First possibility. Planet 9 was born here, in the early solar system, 4.5 billion years ago, when the sun was surrounded by a swirling disk of gas and dust. Several giant planets were forming. It's possible that Planet 9 was once among them, a sibling of Jupiter, Saturn, Uranus, and Neptune. But in the chaos of those early days, it might have had a close encounter with Jupiter, the solar system's bully. Jupiter's immense gravity could have flung Planet 9 outward, ejecting it to the edge of the solar system. Not fully lost to interstellar space, but stranded in a distant, lonely orbit. Second possibility. Planet 9 was never ours to begin with. It could have been a rogue planet, a lonely world wandering between the stars. At some point in the sun's youth, when it was still part of a stellar nursery filled with sibling stars, the sun's gravity might have captured this passing planet. Trapped by chance, Planet 9 could have been adopted into our solar system, becoming a permanent but hidden member of the family. Both scenarios are dramatic. One, a survivor of early planetary chaos. The other, a cosmic orphan adopted into our system. Either way, Planet 9 would be a living link between the world of rogue planets and the solar system we call home. Now, let's step back for a moment and think about what this means for humanity. If Planet 9 exists, and we confirm it, it would be the first new planet discovered in our solar system in over 170 years, since the discovery of Neptune in 1846. Just imagine. For generations, we've taught children that the solar system has 8 planets. Finding a 9th would fundamentally rewrite our cosmic address. It would also be a profound reminder that the solar system is not as settled or complete as we once thought. Even in our own backyard, mysteries remain. Vast worlds could be hiding in the shadows, waiting for us to uncover them. And perhaps most humbling of all, Planet 9 would prove that our sun is capable of shaping, capturing, and harboring worlds on a scale we've only begun to imagine. So far, no telescope has seen it directly. But the evidence, written in the orbits of distant icy bodies, continues to point toward something massive out there. Somewhere beyond the edge of the known solar system, a lost giant may still be waiting. And if we find it, the story of the solar system will never be the same again. Up to this point, we've been talking about rogue planets and the possibility of a hidden Planet 9. But here's the big challenge. How do you actually find something that doesn't shine like a star, and maybe hundreds or even thousands of times farther away than Earth? This is where astronomy becomes a detective story, using clever methods to reveal the unseen. Let's start with rogue planets. Unlike stars, they don't emit light of their own. They're cold, dark, and practically invisible against the backdrop of space. But they do have one powerful trick: gravity. One of the most important techniques is called gravitational microlensing. Here's how it works. Imagine a rogue planet passing in front of a distant star. The planet's gravity bends and magnifies the light of that background star, just for a short moment. To us, it looks like the star suddenly brightens, then fades again. By carefully watching millions of stars, astronomers can catch these tiny flashes and deduce that a rogue planet has crossed our line of sight. This is how we know that rogue planets may actually be extremely common in our galaxy, perhaps even more numerous than the stars themselves. Each microlensing event is like a footprint, evidence that a hidden world has just walked by. But what about Planet 9? Here, the challenge is different. Planet 9 isn't completely invisible. It should reflect faint sunlight, just like Neptune or Pluto. The problem is that it's unimaginably far away, moving very slowly against the starry background. Searching for it is like trying to find a single moving grain of sand on an endless beach. So how do astronomers attempt this search? One key tool is the Subaru telescope in Hawaii, one of the most powerful wide-field telescopes in the world. With its huge mirror and sensitive detectors, Subaru can scan enormous swaths of the night sky at once, looking for anything faint and slowly drifting. Another upcoming game-changer is the Vera C. Rubin Observatory, formerly known as the LSST, scheduled to begin operations soon. This telescope will take high-resolution images of the entire southern sky every few nights. Over time, it will build up a movie-like record of everything that moves: asteroids, comets, distant icy bodies, and possibly Planet 9 itself. And then there are infrared surveys, because very cold objects still emit a faint glow in infrared light. Space telescopes like WISE, Wide Field Infrared Survey Explorer, have already scanned the sky to look for large nearby planets. While WISE didn't find a Jupiter-sized world, the data docent rule out something smaller and more distant. Exactly what Planet 9 is supposed to be. The search also requires persistence. Astronomers spend years combing through terabytes of data, carefully checking faint smudges of light to see if they move differently from stars. Most turn out to be false alarms, background galaxies, noise in the detectors, or known objects. But every so often, there's a candidate worth following up. It's a bit like playing cosmic hide-and-seek. Planet 9 could be out there, waiting, but the sky is vast, and the planet could be anywhere along its gigantic orbit. Finding it will take patience, teamwork, and technology at the very edge of what we can do. But let's not forget, even if Planet 9 doesn't exist, these same methods are uncovering new worlds all the time. Every strange orbit in the Kuiper Belt, every microlensing flash, every faint moving dot in a telescope image is a reminder. The solar system and the galaxy are still full of surprises. And if we do find Planet 9, that moment will go down as one of the greatest discoveries in the history of astronomy. For the first time in over a century and a half, humanity will have added a new planet to the solar system's family portrait. So the search continues, night after night, telescope after telescope. Somewhere out there in the dark, a lost world may already be waiting for us to notice it. At this point, you might be asking, why should we care? Why should astronomers spend years of their lives chasing faint dots of light, or waiting for a tiny flicker in the sky to reveal a rogue planet passing by? What difference would it really make if we discovered Planet 9, or found proof that rogue planets are everywhere? The answer lies in what these worlds can teach us. First, they hold the key to understanding how solar systems form and evolve. For decades, we thought planets formed in neat, orderly ways. Dust collects into rocks, rocks into planets, and the planets circle their star like clockwork. But rogue planets show us that the universe is far messier. Gravity doesn't always play nice. Worlds can be born and then thrown out, like children exiled from their family. Planet 9, if it exists, would be a fossil record of those violent early days. Evidence that the solar system had a chaotic past, far wilder than the tidy diagrams in textbooks. Second, rogue planets may help us answer one of the most profound questions in science. Are we alone? At first, the idea sounds absurd. How could a planet, drifting alone in the cold darkness of interstellar space, ever host life? But consider this. Many rogue planets are thought to be as large as Earth, or bigger, with thick atmospheres that could trap heat. Some might even have subsurface oceans, warmed not by sunlight, but by the heat of their own radioactive cores. If that's true, then life could exist in places we never imagined. Not just in the habitable zone around stars, but floating in eternal night. It's a radical shift in perspective. Life, perhaps, does not need starlight at all. It only needs the right chemistry, energy, and time. If rogue planets are common, then the chances for life in the galaxy could be far higher than we've ever guessed. Third, these worlds force us to rethink our place in the cosmos. For centuries, humans imagined the solar system as something fixed, complete, and well understood. First there were 6 planets, then 7, then 8, then 9 with Pluto, and then back to 8. Each discovery was a moment of humility, a reminder that the universe is not built around our expectations. Now, Planet 9 stands as a challenge to our arrogance. If we find it, we will have to admit that we missed an entire planet in our own backyard for centuries. If we don't, then the strange orbits of Sedna and its cousins still whisper that something massive is out there, beyond the limits of our knowledge. Either way, the lesson is the same. The solar system is not finished revealing its secrets. And beyond the science, there is something deeply human about this search. Rogue planets and Planet 9 speak to our imagination. They remind us that the universe is not a static picture, but a living drama of creation, destruction, exile, and survival. They are symbols of loneliness and resilience. Worlds cast adrift, yet still carrying the memory of their origins. Perhaps that's why the idea captures so many hearts. When we look for Planet 9, we're not just searching for a rock in space. We're searching for connection, proof that the cosmos still has mysteries waiting to be uncovered, and that our story is still being written. In the end, the pursuit of these lost worlds matters because it expands the horizon of the possible. It tells us that the galaxy is richer, stranger, and more alive than we dared to believe. Whether we find Planet 9 tomorrow, in 50 years, or never at all. The very act of looking is a declaration. That curiosity is at the core of what it means to be human, and who knows, one day, far in the future, explorers from Earth may set foot on a rogue planet, walking beneath a sky with no sun, lit only by the glow of distant stars. When that day comes, it will be because we once asked a simple question: do lost worlds exist? We began this journey with a simple, haunting image. A planet, alone, drifting through the endless night of interstellar space. No sun, no warmth, just the cold glow of distant stars. And yet, as we've discovered, these are not just lonely rocks scattered at random. They are pieces of a greater story. Fragments of cosmic history that tell us how worlds are born, how they can be lost, and how the universe is always larger and stranger than we imagine. Rogue planets remind us that order and chaos go hand in hand. Our own Earth could easily have been thrown into the void billions of years ago. If the gravitational dice had rolled differently, we would not be here to wonder about these mysteries. In some ways, every sunrise we experience is a miracle. Proof that our planet stayed bound to its star, when countless others did not. Planet 9, if it exists, represents a different kind of wonder. It would not be a wanderer exiled into the galaxy, but a survivor, a hidden sibling of Earth, circling in the darkness, far beyond Neptune. To find it would be to admit that our map of the solar system has been incomplete all along. It would be a new chapter in the same story that began when Galileo first pointed a telescope at Jupiter's moons, showing us that the universe holds far more than we ever thought possible. But even if Planet 9 is never found, the search itself carries meaning. Every telescope scanning the sky, every researcher combing through data, every flicker of a distant star captured on a CCD chip is part of humanity's great experiment. To look outward, to ask questions, and to keep asking no matter how hard the answers are to find. And maybe that is the real point. These lost worlds matter not only because of what they are, but because of what they make us do. They push us to invent new tools, to expand our vision, to rethink old assumptions. They remind us that discovery is not about comfort or certainty. It's about stepping into the unknown, guided only by curiosity and courage. So, what should we take away from all this? That the solar system is not a finished story. That beyond the planets we memorized in school, beyond the icy edge of the Kuiper Belt, there may be other worlds waiting. Some cast away, some hidden, some carrying oceans under frozen crusts. All of them whispering the same truth. The universe is bigger, wilder, and more alive than we ever dared to dream. As you close this video and look up at the night sky, I want you to remember one thing. Somewhere out there, drifting in the shadows or circling in the darkness, a lost world is waiting to be found. It may take years, decades, even centuries, but eventually, humanity will uncover it. And when we do, it will not just be a scientific discovery. It will be a reminder of who we are. Explorers, dreamers, wanderers ourselves. So let's keep looking. Because the lost worlds of the universe are not just out there. They are a reflection of us, of our endless hunger to know, to understand, and to belong in a cosmos that still has secrets left to share. This is not the end of the story, it's just the beginning. And now, I want to hear from you. Do you think Planet 9 is really out there, quietly circling in the dark? Or are the strange orbits of Sedna and the other ETNOs pointing to something else entirely? Share your thoughts in the comments below. I'd love to know what you think. And if you enjoyed this journey through the lost worlds of the universe, make sure to give this video a like and subscribe to the channel. That way, you won't miss our future explorations into the mysteries of space. From the birth of stars to the fate of galaxies. Every click, every comment, every share helps this community grow. a community of curious minds who believe that the universe is worth exploring. So, stay curious, keep looking up, and remember, the next great discovery might be waiting just beyond the stars.